Hello, everyone, and welcome to this audio podcast. This audio podcast is part of a Storm Robotics article. This audio podcast as part of a Raptor Storm. This audio podcast as part of a Platinum Edition, and this audio podcast as part of a Storm Robotics production. In this audio podcast today, looking at the genetics around some of the genetics of Crouzons or Crouzon syndrome. So, inherited in an autosomal dominant a pattern which means that one copy of the altered gene in each cell is sufficient to cause the disorder or the condition, and mutations occur in the FGFR2 gene, which geneticists have identified as chromosome 10, cause Crouzons. The FGFR2 gene provides sort of the instructions, if you like, for making the protein called fibroblast growth factor receptor 2, i.e., the abbreviation FGFR2. And the protein FGFR2 protein is important in bone growth, but also particularly during embryo and neonate development. And mutations in FGFR2 are probably overstimulated. Oh, sorry, probably over sort of stimulate signaling by the FGFR2 protein, which causes the bones of the skull to fuse prematurely. In some cases at the same time, an affected individual inherits the mutation from one affected parent, and these cases occur and have occurred in people with no history of the disease, the disease or the condition within the family. And Crouzons with acanthosis nigricans is caused by changes in the gene FGFR3 mapped onto chromosome 4. The cause in around the sort of the FGFR3 mutation, although mapped onto chromosome 4 and identified with acanthosis nigricans. This the cause is not or overly sort of known. If a parent has Crouzons, if a parent has Crouzon syndrome, there is a probability of around 50%, that a child will develop Crouzons. That draws this audio podcast to a close. This audio podcast is part of a Storm Robotics article. This audio podcast as part of a Raptor Storm. This audio podcast as part of a Platinum Edition. And this audio podcast as part of a Storm Robotics production.